morning to all. For today's session, we are discussing the solid mechanics topics. So in this class, we are going to discuss the laws of uniform processing with the multiple of loads, under which we are going to find what is the total extension as well as the extension in each bar. So how to find? So that is the aim of this topic. Okay. So let's have a bar contains three sections. Section 1, this is the section 2, this is section 3, which is represented by A, B, C, D. And it is acted upon not a single load as earlier. It is acted upon different loads at different points. There is a multiple of loads here, or internal loads. So at the extreme and left extreme it is P1, and at point P towards right side P2 and here P3 and here P4. So totally 4 loads are being acted upon this. So how to find? As we know that we are going to find what is delta here, total extension. So the L is here, the L value is total length L1 plus L2 plus L3. Okay. So we can use PL by A, the same formula we are going to use. Okay. But for each section, I should know what is the load, so that I can use P L by AE. So let's have the diameter here. The area is A1. Okay, let's take this is the area. A1 is known, and A2 is known value. A3 is known value. Like that we can take. So no problem at the area. In each section we are having the area. Okay, and the length L1, L2, L3 we are having. And Young's modulus, you can say that Young's modulus also known. It is same, uniform. It is made of single material. Like that you can take. So this value also known value. So we have L1, sorry, L2, A value as well as E value. These are all known values. One of the thing is multiple of loads are applied on. So what is the load in each section? So we have to segregate the section AB, BC, CD. Okay, we have to segregate each section and find what is the load acting on each section. So that is the thing. So now let's take section A first. So this is A and this is B, and this is the length is L1, area is A1. Okay, and the X one is trusses. So what are the load? So since it is the left extreme end, one important concept I am saying that since it is left extreme end, you can put the load as it is. Here it is P1. Here also it is P1. Okay. So like that we can say. So before going to start with the segregation, we should check whether equilibrium existing or not. We should find the equilibrium existing or not. How to find the equilibrium? How to check? The equilibrium is such that the net effect of force. The net effect of force is equal to 0. That means the sum of forces is equal to 0. Okay. So here the loads are acting towards the side like side. So this we have a sign convention. The sign convention is take is up to you only. Okay. I am taking towards right. I am taking this positive. Towards left is taken as negative. Okay. So since it is P1, it is minus P1 plus P2 minus P3 plus P4. That is equal to 0. That must be equal to 0. Then only equilibrium condition exists. After that we can go for the solution. Okay. So like that we should find it. Okay. So this is about the equilibrium check. Okay. If equilibrium existing, then we can go on to the segregation of each section. So I told you since this AB, here the left extreme end directly put the load P1. Since it is P1, that is also must be equal to P1 because each section must have the equilibrium condition. The P1 and the P1. Okay. Next, how to find the BC section? Okay. Section BC, how to find? So here BC So this is length L2, area A2, okay, area A2, X was there, the load I have to find. So this point is B, this point is C. Here. Okay. So we have two kind of thing we can check. Okay. Now I am going to find what is the load at the B. Okay. At the B, what is the load is acting. And the same load is acting at the C also in the opposite direction. Okay. Okay. Now, since it is BC, B is in the left side. B is in the left side. So just go here and B point. We consider from the line. Consider left side. Okay. Since it is left side. Okay. So from that, we consider. So this load also at the B only. We consider this one. This load plus this load. Okay. We consider P2 and P1. So P2 and P1 you have to consider. You have to P2 and P1. You have to consider and you have to come up with the sign convention. Since P2 is towards right, that is positive value, and towards left P1, it is taken as negative. So P2 minus P1. That is the load here. You can find it. So P2 minus P1 is value, and if it is positive, we should towards right. Okay. If it is positive, it goes towards right side. Okay. If it is negative, it goes towards left side. Okay. Now let's check. Take P2 minus P1 if it is positive. Okay. I am taking P2 minus P1 is taken as positive. What happens? So after B point only I am taking. Okay. So it goes towards right side. This is P2 minus P1. So it is also same value in the opposite direction, P2 minus P1. Okay. Then you can move on to the another section called as C. C section. So it is C, and this is D section, D point D. Okay. Now I am going to find what is the load. So as is L3 and then area is A3. What can I check? Since it is the right extreme section, I told you at AAB, you just without converting anything, you just go for the same load. As well as it is about right extreme end. Okay, right extreme end. So put directly the value of the load, what it is here, P4. So it is also P4. Okay. Otherwise, you can move on to the next. Otherwise, I will take another thing. Okay. I will go for another thing. Now I am going to have a point C. So take this point C. So C in the left side in CD, you consider left side alone. If you take right side means this one alone P4, so it will come back to. Okay, now I am going to find what is the load is acting at C. Okay, so my aim is to find the load at C means you just follow up C here, let's say. So you will have P3, P2, P1, P3, P2, P1. So P1 towards left, it is negative value, P2 towards right, that is positive value, and towards left P3, that is negative. Okay, so this is the load here it comes to. Finally, this load is equal to nothing but this P4 only. Okay, since it is equal here. Okay, so like that also we can go for to find the loads at the C or D, but for immediately can do it is extreme in the put its value D by the same value the C but in the opposite direction. Like that we can have. So this is about how to segregate the loads on each section, and finally we can go for the finding the delta L at the AB. So it is nothing but P by AD. Another thing is this load P1. Okay. Here what we have found. Okay. Either the delta L BC, delta L CD. Here the corresponding load for each section we find and get the value. Okay. And what about the delta L? Delta L is equal to delta L1 plus delta L2 plus delta L3. Is it correct? Actually, it is correct, but with sign convention. Okay. Now, in this section, it is tensile load. Okay. If you apply the tensile load, the extension will happen positive. If you are taking BC, assuming that there will be a compression load, what happens? If you compress, the length will be shortened. Okay, so there is a decrement in length. And here, let's take an increment. So like that, if it is there, delta L is nothing but delta L1 which is positive, and BC there is a compressive load acting on. So there will be decrement length. So you have to minus. Okay, sign convention it is decreasing. Delta L2 and then in L3 it is tensile load. Okay, like this happen. So we have to apply the same formula. You have to sum up all the values of changing length. But if there is a decrement, that means in case of loads are compressing, okay, you have to subtract the changing length. So again you have to use it. That is the correct methodology to find the total extension. Don't add all the things. You have to add all the things with the sign convention. Okay. So that's all about in today's class with the multiple of loads acting on the one single block with containing 3 balls, 3 sections for uniform cross-sectional area to find the total extension, total change in length. Okay. So we will see the next class the different topic. Thank you.